So for this one, there's a couple different ways to solve this problem up here. I'm going to show you the way I did it. Again, a couple different ways. So the first thing I saw on this one, this half is going to equal the same resistance of this half. So that has to mean that this 6 amp source has to split 50-50 through both. Otherwise, I'd have to use a current divider equation to calculate out, let's just say this was a 3 over here, use the current divider equation to calculate out which percentage is going to which side, but we don't even need to do that. This is half of this, and it's going through here. We also know that the 2 on the I1 is going to equal the 2 on the I3 because it's split again evenly. So we have a split coming out, and half of it's going this way, half of it's going this way, and then I have a split of a ratio 2 to 4, and then again I have a ratio 2 to 4. So I know, first off, I1 equals I3, I2 equals I4, and we know that the circuit is split 50-50 down the side, so that's going to make this really easy. I redrew the circuit as this. We have a 3.5 amp source. We have a going around, I have a going down, I have a node, I have a this back to the top. And then this one's going to be 2, and this is going to be 4. So that's the circuit we're solving now. It doesn't look nearly as bad. So how we're going to do this, you can use the current divider equation, because we're going to use it for this part. Again, you could use it again up here in the beginning of the problem, but I didn't. I just wanted to save one step and one current divider. This was faster for me to do it. But current divider equation. Current, not divider. Okay, I'm going to box that out. We've got I1 equals R2 over R1 plus R2 I. Okay? What is our I? This is our I here. I equals 3.5. It's the one coming out. So I1, which is the current, the current going through this first bit of the part, equals R2, which is that's the other one. So that is 4 over 4 plus 2 equals 6 times our I, which is 3.5. I1 equals 2.33 amps. Somebody wrote, oh man, that's a big number on your test. Yeah, it's a lot of current. It's a good chunk of current. Totally mathematically doable. And I mean, you have a 6 amp source here too, so that's going to be pretty high. So that's our first one. So we know I1 equals 2.33, and we know this equals I3 as well. And then for I2, what do we do? Kirchhoff's current law. I don't want to solve this whole thing again and swap them out. I want to make this nice and easy. So I'm going to do 3.5 minus 2.33 equals I2, and that's going to be 1.17 equals I2 equals I4, 1.17 amps. I left the unit out for that. Anyway, you see how that one works. Cool. Let's do the next one here. What do we got for this? This one was a fun one. So I look at this one first. I got this little tiny circuit over here, and I've got this loopy kind of circuit over here. And this one depends on whatever's happening over here. So I know I have to solve this one first as my entry point. So first bit, V equals IR. What are we talking about? We're talking about trying to find the voltage V0 here, first off. So we've got the current, we've got the resistance, so we can find V0. So V0 equals 0.01, 10 milliamps. 1, 2, 3. Move the decimal. 1, 2, 3. Point that. So 10 milliamps times resistance 2K, which is 2,000 ohms, equals 20. That's our V0. 20 drops. That's your first part. Equals V0. First one done. To the second part. Now we're going to try to find this part over here. It says power going through the 3K ohm resistor. So, again, couple different ways of solving this. You're going to need the V0, though, to plug into this part of the equation. So we've got V1, voltage 1, which is the voltage going through this, because remember, power equals voltage times current, so we need that part, equals, what do we got? 10 to the minus 3, 10 to the minus 3 times V0, which is 20. Okay, that looks good too. And then V equals I, so that's your current source, and then R is going to be, what, 3,000, right? V equals I'll box it for you. I, which is a current source, we know from that symbol, it's a current source, so that is the current, R. So that's going to equal 60 volts equals V1. 60 volts equals V1. Okay, so now we know the voltage drop over this. So our next equation, power equals IV. We're going to solve that one. Power equals our current source, which is 10 to the minus 3 V0. And V0, again, we found to be 20. 10 to the minus 3 times 20. And then we need our voltage in here too, times 60. And that's going to equal 1.2 watts. That one wasn't too bad. I like that one.